Here's our second example of balancing chemical equations. And here's the chemical equation that we have. Sodium is reacting with oxygen to produce sodium peroxide, Na2O2. And so we want to balance this to show that this reaction follows an important fundamental law of chemistry, the law of conservation of mass or matter. So the first thing we have to do is envision a line going down the middle of this reaction, separating our reactants from our products. And now, next, let's determine what kinds of atoms are present. Sodium atoms are present. Oxygen atoms are present. The next thing to do is to do an initial count of each kind of atom. Well, on the left side of this chemical equation, I have one sodium atom to begin. On the right side, I have two. On the left side, I have two oxygen atoms to begin, and on the right side, I have two. What this tells me is, from the very beginning, that this reaction is not balanced. Somehow I went from one sodium atom to two sodium atoms, although the number of oxygen atoms is balanced. So what this means is I somehow managed to create matter from nothing, which violates the law of conservation of mass or matter. So what I need to do is adjust coefficients to make this balanced. So how can I make this 1 a 2 is the question I need to ask. I cannot ever change subscripts when trying to balance. If I change the subscript, I change the chemical and thus change the reaction. The only way to force a chemical equation to become balanced is by adjusting the coefficients. Right now, each coefficient is 1. There's a 1 here. There's a 1 here. If you don't see a coefficient, you assume it to be a 1. So I can make this, on the left side, I can make this one sodium atom actually two sodium atoms by changing the coefficient here from a 1 to a 2. Every time you change the coefficient, you need to stop and recalculate. So this 2 was for this substance, so this recalculates to two sodium atoms. I still have two oxygen atoms, and the right didn't change at all because I didn't adjust any coefficient on this side. This is still a 1. So if I look now, this appears to be balanced, and that was already balanced. So my new balanced chemical equation would be 2Na plus O2 yields Na2O2. The coefficient here is a 1, and here's a 1. So what does the balanced chemical equation give you, really? The proportions in which these substances react with each other, are produced or consumed. This means I need twice the amount of sodium than oxygen to produce this sodium peroxide. 2 moles of this for every 1 mole of this create 1 mole of this.